Hello everybody, in this video we're going to talk about how to find domain and the vertical asymptotes of a rational function. So to summarize, rational function is anything with an x in the denominator. It could be polynomials. You could also have it on the top and bottom. But the idea is that there is x on the bottom. So anytime the denominator is equal to 0, 1 over 0, 5 over 0, whatever. With 0 in the denominator, the graph is undefined. At these x values, to make the bottom 0, there will be a vertical asymptote on the graph that goes down, depending on where it is. And rational functions are shaped to where you don't touch because it's undefined at those points. So let's say we're given 1 over x squared minus 4. How would we find the vertical asymptotes for this? Well, we said that we just need to figure out where it's 0, 1 over 0. So we can set the denominator equal to 0, and we can say it cannot be 0 because that's where it'll be undefined. So x squared cannot be 4. X squared cannot be plus or minus 2. Oops, that should be x. Yeah, so x cannot be plus or minus 2. So on the graph, that would look something like 2 minus 2 and the asymptote that goes along this line. Okay, so what about the domain for this then? Well, it just cannot be these 2 points. So other than these 2 points, everything else seems to be good. So we could either say x cannot be plus or minus 2. This will work for this question. Or to write it in union notation, interval notation, as I say. Minus infinity minus 2 in union with 2 to infinity. And there we have it. Okay, let's look at a more difficult example. Okay. Let's say we have one that is x minus 4 and x plus 2. Okay, so this one's a little different because there's a square root. However, we can still find the vertical asymptote the same way. So x plus 2 cannot be 0. X cannot be minus 2. Okay, so let's go ahead and graph just that part. It cannot be minus 2. Okay, so but how do we deal with the square root? Well, square root, you can't have a negative inside because that'll lead to an imaginary number. So it must be positive. So you can say x minus 4 has to be greater than or equal to 0. X has to be greater than or equal to 4. Okay, so based off of that, they're saying the graph only exists on the right side of this 4. So what would the domain be for this? Well, to write the domain, we don't even really need to include this because the graph is from 4 and on. So you can just write x is greater than or equal to 4. That would be your answer.